Welcome back. This PowerPoint is not as complex or as long as the previous PowerPoint. However, we'll review some interesting concepts that you've heard before, such as estimation, hypothesis testing, and statistical significance. These are foundational concepts that will be used when we conduct inferential statistics techniques. I hope you'll find this PowerPoint useful. As always, please read your textbook prior to viewing this PowerPoint to enhance your understanding of the discussed concepts and formulas. You have heard the term hypothesis. For example, you may hypothesize that this is one of the most difficult courses that I have taken in my academic career. A hypothesis describes in concrete terms what you expect will happen in your study. We use a hypothesis when we have prior knowledge of the findings in the literature, which assists you in making a tentative statement about the relationship between variables. Studies that are exploratory in nature and that use a quantitative approach may use a research question instead of a hypothesis. There are two types of hypotheses. The first type is a research hypothesis or alternative hypothesis. It is a tenable and testable statement or prediction about how changes in the independent variable will impact the dependent variable. Another type of hypothesis is a null hypothesis. This type of hypothesis assumes that there is not a relationship between the hypothesized variables in the population and that any change is attributed to sampling error. We do not test our research hypothesis. However, we attempt to reject our null hypothesis or prove that the changes did not occur by chance. Statistical hypothesis testing is the procedure that evaluates hypotheses about population parameters based on sample statistics. This testing determines whether or not sampling error is attributed to the relationship between the variables. When we develop a hypothesis, we consider 5 sequential steps. Step 1. Make assumptions by considering the following: level of measurement of variable, method sampling, probability or non-probability, sample size, and literature review. Step 2. State the research or null hypothesis. Step 3. Specify the significant level. Step 4. Select and compute the test statistic. Step 5. Make a decision regarding the null hypothesis. The following provides an example of the steps in hypothesis testing. The research hypothesis is, after receiving an anger management intervention, women's anger scores will be significantly less than men's anger scores. Our null hypothesis is, after receiving an anger management intervention, anger scores will not differ between men and women. By convention, the significance level typically selected is 0.05, where we are willing to erroneously reject a null hypothesis 5% of the time. Or, put another way, the researcher is willing to appropriately retain the null hypothesis 95% of the time. The significant level or alpha level selected is reported in terms of a lowercase and italicized p. It's likely you've encountered statements in the literature such as, "This difference was significant at the p is less than 0.05 level." This p in this instance stands for probability, and the expression itself is really just a shorthand way to say that the findings reported would be expected to occur by chance less than 5% of the time. The decision in selecting and computing the test statistics depends on the study question, the presence of the normal distribution of values for continuous level variables, and the type of sampling procedure. Our final steps require us to decide to reject or accept the null hypothesis. When the statistical test is completed with the assistance of statistical software, the decision regarding the null hypothesis is made based on the basis of the actual probability, or p-value, calculated. Specifically, if the p-value obtained for the sample statistic is greater than the alpha level selected, or significance level, it's appropriate to conclude that the sample association or difference observed is not statistically significant. The null hypothesis assumes that there is no relationship between our hypothesized variables in the population and that any findings are attributed to sampling error. The null hypothesis always opposes the research hypothesis. When the probability that a sampling error accounts for the relationship between the variables of the sample is low, that relationship is said to be statistically significant. There are two types of hypotheses. The first type is a two-tailed hypothesis or non-directional hypothesis. The hypothesis will state that a change or a difference will occur, yet no direction is given. For example, age is related to knowledge of HIV/AIDS risk factors. This hypothesis does not state if an increase or decrease in age increases or decreases HIV/AIDS risk factors. Another type of hypothesis is the one-tailed hypothesis or a directional hypothesis. This hypothesis provides information regarding the direction of how two variables are related. For example, younger individuals, less than 45 years of age, have more knowledge of HIV/AIDS risk factors compared with older counterparts or those who are 45 years or older. Here's a depiction of a distribution of depression scores where the research hypothesis is two-tailed. For this example, the research hypothesis does not indicate that the depression scores will increase or decrease.